We have all tried the Tor browser at some point, and it's a great little tool. If you're looking to view some sketchy sites on the dark web, then you probably want to continue using it as it hides some information that other browsers give away about your device and also lets you resolve .onion sites automatically. However, if you don't care about the browser fingerprint as much, and you're more interested in bypassing regional restrictions for free, or perhaps you would like to run various other services through Tor, well then you're going to love this video. We're going to use our new SOX5 feature to turn one of your router's ports into a Tor port. It doesn't matter what you plug into this port, any services on that device will only be able to get online through Tor, whether they like it or not. SOX5 will do the proxy part for them on the fly. Before we get into the configuration, I have to warn you that this is not for streaming services, as they usually rely on UDP traffic, but Tor is based on TCP. However, you might find exceptions. For example, I was surprised to find that YouTube works because it does fall back to TCP when UDP fails. And then I heard that Netflix and Hulu supposedly use TCP by default, so those might work too, but I didn't try. Anyhow, we got quite a few steps ahead, so let's get started. You will need a router that can run containers. I will use RB5009, but the specs don't need to be very high. The container will only take up about 150 megabytes of RAM and something like 5 megabytes of storage. I will turn Ether 8 into my Tor port, and I'll just leave the laptop plugged in there, but if you're following along with the configuration, you'll want to enter the commands from one of the regular ports. Let's add a vEth interface only specifying that it needs to use DHCP. We can then create a separate bridge for our Tor traffic and add the vEth interface along with the Ethernet interface we want to use for this purpose. We're going to need a DHCP server running on this bridge, so once we have an address on the bridge, we can quickly complete the DHCP server setup. This is pretty straightforward. Just make sure you set send DNS to yes and you specify the bridge address as the DNS server. With this, check your DNS settings. The allow remote requests has to be set to yes so that your router can act as a DNS server. Then before we add the container, we also need to check if we have NAT masquerade configured in a way that will cover the container traffic. Mine is set with out interface Ether1, but if you're using the default configuration that comes with our smaller routers, yours might say out interface list WAN. The default configuration is fine, but in that case, you might have to update your LAN interface list with the new bridge, because the default firewall is configured to drop everything that is not coming from the LAN interface list. Moving on to the containers section, you will need to change the registry URL to Docker's registry so that you can then pull the Alpine latest image. You could use some ready-made Tor image, but I think it is just as simple with Alpine, and you don't even have to leave RouterOS. We just need some CMD that runs a loop to prevent the container from shutting down. We'll remove it later when everything is set up. With the container extracted, we can start it and shell into it. There we just need to run an update and add Tor. Then we can use the built-in v-editor to open etc tor.torc configuration file. Here we have to type in SOX port along with the IP address of our container and the port 9050. Then press escape and enter column WQ command to save and quit. I already knew my container's IP, but you can find it with the IP address command. And before we forget, we need to also pop open the DHCP server leases and make the new container address static so that there are no annoying surprises later. Okay, we can start a Tor service. It needs to go through this bootstrapping process, and once it reaches 100%, you know your container has connected to the Tor network. For now, we will leave this terminal open as it could provide useful feedback if we mess up in our further configuration. Next up, we want to set up the Soxify service in RouterOS. It needs to use the same port as we configured in the container, and the server address is the container address. Then we have to go to the NAT section and we can start funneling traffic into our Tor proxy. To prevent a Tor loop, we have to first simply accept traffic coming from the container as it is already heading where it needs to go. Then the next rule takes everything in the DST-NAT chain and sends it to the Tor SOCKS5 proxy, as long as the source address matches the network we have configured for this purpose. At this point, we have the basis for our Tor port setup, and we can see some fruits of our labor, but it will be apparent in a second we are not done yet. If we open check.torproject.org from the newly configured port, we get greeted with a congratulations, this browser is configured to use Tor, and the IP address displayed definitely belongs to one of the Tor exit nodes. But there is an issue. If we capture network traffic on the uplink and simply filter for DNS, we find that every website we open from our browser is displayed in plain text. This happens because regular DNS is based on UDP and there is no encryption. To hide this information, a good start would be to switch to DNS-over-HTTPS. Back in our DNS settings, I will specify the Google DoH address, but you can use whichever provider you like. Then change the Verify DoH cert setting to yes and add a static entry so that you can remove the IP address from servers. This way, you can be sure that a regular DNS request will never be made by the router. Regardless of the DNS provider you choose, you should check the certificate built-in section. It should contain the root certificate needed to verify the provider. In my case, I have to manually import GTS root R1. If you're not sure which root cert you need, usually you can check that from the browser. If you look at the site security settings, there are certs displayed, and you can download the root there. Now let's open some random websites and check the uplink traffic again. Great, there is no DNS, but you can still see that there is encrypted traffic going to Google. For most people, this is good enough, but because DoH uses TCP, we can go further and run our DNS through Tor as well. To do this, we have to add another SOCKS5 NAT action, but this time for the output chain, targeting the Google IP address. For an immediate effect, we also need to kill the open TCP connections. And now, when we look at our traffic again, there is no sign of DNS requests or the IP address that we are actually using for DoH. The DNS is optimized for the Tor traffic. Whenever we are getting any CDN resources, they should come from the region of the Tor exit node that is currently being used. For Tor traffic, this is great, but when it comes to regular traffic, it might not be what you're looking for because it could slow things down on top of any latency that the Tor network is already adding. But not all is lost, because you can still continue using regular DNS for your non-Tor traffic and use DoHoT for Tor. A simple way to achieve this would be to change the DHCP server settings and change the network configuration for your regular LAN. I will set it to Cloudflare DNS for a change. Now, if we switch to a regular LAN port and open some websites again, then capture traffic and look for DNS, we can see that the Cloudflare IP address is used as expected. This DNS part got pretty complicated, and I think the takeaway is that you have multiple options with their own trade-offs. I would suggest you choose for yourself whether you would like to use simple DoH, DoHoT, or a combination with regular DNS for the things you don't need to hide. Before we wrap it up, we have to configure a couple more things though. First of all, we are only applying SOCKS5 to TCP traffic, which means UDP traffic could still get forwarded. And we also want to make sure that if something happens with our Tor setup, there is no way for the Tor traffic to suddenly just leave the router without encryption. We need to add two firewall rules for the forward chain. First one needs to accept traffic coming from the container and heading out the uplink. The other rule needs to drop everything from the network we have made for our Tor configuration. Now again, if you're using the default configuration, you will have other firewall rules there. And if this is your WAN-facing router, you absolutely should have a firewall configured. This means that you need to fit in these two new rules correctly into your existing setup. Usually this will simply mean that you move these two rules above any other rules that are in the forward chain. Finally, the last thing that we need to do, stop the running Tor and the container itself. Then change the CMD to simply Tor. and the start on boot to yes. Sometimes the container settings might still be locked up after just stopping it, and you might need to reboot before you change anything. But once you have done this, everything is ready to go. On your next boot up, the container will be running and the Tor port will be secure to use without any concerns that you might not be connected to the Tor network. I hope you enjoyed this sort of learn all the details step-by-step approach. There are ready-made Tor solutions out there, and we might even turn something like this setup into a one-click solution at some point ourselves. But I think you have gained a much deeper understanding of this topic if you followed along. Thank you for watching.